Good day, everybody. This is Arjun from Emurgo. So today we are going to see how to set up a multi-node private Ethereum blockchain. This is going to be a completely hands-on technical session. So in this tutorial, we will set up a blockchain with multiple nodes. We'll set up different mining nodes. We'll connect the multiple nodes and set up the blockchain network. We will also test the blockchain network by mining blocks and verifying that blocks are propagated to all the nodes. Finally, we will verify that the local copy of blockchain on all nodes is updated. So without further ado, let's get started. So first you'll have to install this Ethereum client called as Geth. You can probably find that here at geth.ethereum.org. So Geth is the Ethereum node software that is coded in the Go programming language. Geth can be used with different commands. It comprises different management APIs. Some of the common management APIs for setting the Ethereum node are eth, personal, admin, debug, and miner. So Go Ethereum or Geth is one of the three original implementations of the Ethereum protocol. It is licensed under the GNU LGPL version 3. It is available either as a standalone client, which is referred as Geth. You can install Geth as a library in different operating systems, Android or iOS. So Geth is a multi-purpose command line tool that helps in the execution of a full Ethereum node implemented in the Go programming language. The downloading and installing of the Geth tool do not require much space. The memory space is required by the blockchain that is downloaded by the Geth tool. So let's go ahead and click install. So here on this installing Geth page, you can see this option which says install from a package manager. So depending on your operating system, you can select one of it. So I use Ubuntu. So let me just go ahead and click this install on Ubuntu via PPS. So this displays certain set of commands which I would have to run in order to install Geth. So let me just go ahead and open my terminal. Let me paste this command here. All right, so this is done. Let me go ahead and update using this sudo apt get update. All right, so I have to put in the last command here. Where do we keep this terminal window? I'd probably just leave it here. Okay, and type in the last command. Okay, so this is going to take probably a few more seconds to get this installation completed. So alright, with the Geth installed, how do we verify if Geth is actually there? So let's open the terminal and use the command get version. Alright, so this is get space version. So once I hit enter, you should basically get these parameters which show that get is already installed in the system. So now what next? So let's configure something called as the Genesis block. So the Genesis block is a JSON file which is going to have the initial configurations of how your blockchain is going to be and how it is going to react. So on that note, let us go ahead and copy the contents of the Genesis block from a URL, which I'm going to display up on the screen now. So let me read it out for you. It is tinyurl.com/y85tzbfa. I repeat, it is tinyurl.com/y85tzbfa. So let me just wait for you guys to open up this URL. And let me do the same here as well. All right, so you should basically land on this page which says Mount Beth Genesis. So you can see here there are some configurations which are mentioned here. You have the chain ID, you have the homestead block, you have other parameters like the nonce, the timestamp, the gas limit, and the difficulty. So people within the blockchain ecosystem will probably identify a few of these few terms. So let's go ahead and copy all of it. Now what do? So once you have copied it, open another new terminal, create a directory or create a folder, a new folder for our project right here. Let's name it mouse belt Emurgo. So how do we make a new directory? We use the command mkdir space mouse belt Emurgo. So let us enter into that folder. We use the command cd space the directory name. So that is cd space mouse belt Emurgo. Alright, so once this is done, let us go ahead and paste this Genesis content within this folder. So we have mouse belt Emurgo. So let me create a new file and let me rename this as genesis.json. Yes, this is extremely important because we will be making use of this file name further. So I've named this genesis.json. So all the developers can also make use of Visual Studio Code or any other editor for creating this file. And then I paste this content here. So this is my genesis.json, which is ready within my local system. Let me go ahead and save it. I use Ctrl S and let me close this file. Okay, so now we have the genesis.json file ready. Let us go ahead and set up the first node or the node 1. So once the genesis.json file is saved, you're ready to create your first node. To create your first node, open a new terminal window and navigate to your project folder and type in the following command. So as you see here, we have already navigated to that particular folder. So let's go ahead and type in our first command. So the first command is get --data dir blk chain 1, which is going to be a node name blk chain 1, and then you give it init space genesis.json. So as you can see, this is where we are making use of this file genesis.json. We're trying to initialize the node. So once I hit enter, you can see there are some configurations which happen. So this command initializes a new blockchain node using the configuration specified in the genesis.json file. By using --data_dir, we specify the name of the directory where the local copy of the blockchain will be stored on the node. This command will create a directory called blk chain1 in your project directory, as you can see here. This directory contains the get and the key store directories. So if I go back to my terminal and say ls, you see blockchain1 genesis.json, you do cd blockchain1, do an ls again, and you see these two folders here, get and key store, or you could probably just manually enter within this folder and check if this get and key store are here. So the blockchain data will be stored in the local database in the get directory. You can verify this by navigating into the blockchain1 directory in your terminal, or coming into this get folder here and manually seeing you have this chain data and light chain data. So now that your node 1 is initialized, let's start node 1 using get. Within your terminal window, navigate to your project folder where you have saved your Genesis file again. So here we go back with the command cd space ... So now we are back into our main folder mouse built Emurgo. Okay, so now what do? We type in this command get space --data_dir space blk chain1 space --node discover space --network id 1234 space console. So this command will start your first node and bring up the get console, where you can type in commands to interact with the node 1 blockchain. As you see here, we are already within the console. So let's break down this get console command and understand it. So --data_dir blk chain1. So this specifies the data directory of the blockchain. If you do not specify this, it will default to the main Ethereum blockchain. Then you have --node discover. This disables the peer discovery mechanism and enables manual peer addition. After which you have --network ID 1234. So this is the identity of an Ethereum network. Other peer nodes will also have the same network identifier. The network ID can be any random integer value. Now that you are in the get console, to get more information about the node, we will use the admin command. So type in the following command in the get console, which is admin.node_info. So this will give the information about your node. So notice the following: by default, your port is 30303. The E node is your node ID. And the discovery port is 0 since we set it to --node discover. To get a list of all admin commands, type admin dot and press the tab key. So these are the various admin functionalities. Now let's set up an account where the mined ethers will be collected. Type in the following in the get console. personal dot new account. Open and close parenthesis. So here you can see it is asking for a passphrase. So this is very similar to your password. So let me give a random passphrase. Hit enter and repeat the same passphrase again. Hit enter once again. As you can see, a new account is created. And it also says please remember your password. So this is the new account created. So with this, the node 1 is ready. So keep the terminal window with the get console for node 1 open and running. We will open a new terminal window to set up node 2. So let me keep the node 1 terminal on the left and the node 2 terminal on the right. So now let's go and navigate again into the directory of a get project, which was cd mouse belt Emurgo. Now we are in here and let us type the get command once again, which is get minus minus data dir blk chain 2, which is the name of our node 2, init space genesis dot json. So since we want this node to be part of the same blockchain, we use the same genesis block, which is specified within this genesis.json. Now to get the node 2 up and running with the get console, type in the following. So we have get space minus minus data dir space blk chain 2 space minus minus no discover space minus minus network id space 1234 space minus minus port 30304 console, and then hit enter. So this will start up node 2 and bring up the get console connected to node 2. Note the following differences for node 2. So here we specify a port number 30304 because the default port is 30303 and it is already being used by the first node. So if we do not specify a separate port, it will throw an error. We give the same network ID. So this is where the port is mentioned 30304. So we give the same network ID as we did for node 1, which was 1234. And we specify minus minus data dir for node 2 will be blk chain 2. So let us run the admin dot node info here as well, and hence we are having this information of this node. So notice that this provides the information for node 2. You can compare the enode ID by running the same admin.nodeinfo command in the terminal window running the get console for node 1. So which is already up here. So this you can see is different from this here. All right. So now we go back to the terminal 2 where the node 2 is residing, and we create a new account there as well. So again the passphrase. So you can see we have an account here for node 1 and an account for node 2 as well. So with this, I would like to say congratulations, you have 2 blockchain nodes running. The next step is to connect them to each other and create a network. We will do this by adding one of the nodes to the other as a peer. So run the following command on the get consoles of both node 1 and node 2. admin.peers. So you can see this has returned an empty array. Let's do that in the node 2 as well. admin.peers, empty array here as well. So since you have noticed that both the nodes return an empty array because both the nodes are not connected to any other nodes. So let's add node 1 as a peer to node 2. So let's go back into the admin.nodeinfo and copy the enode ID for node 1, which is here. Go into our terminal 2 where our second node is running and use this command admin.add peer, open and close parenthesis, and within it paste the value. All right, then we hit enter. Now we go back to terminal 1 and type admin.peers, and now you see it is returning a value here. So which means both these peers or both these nodes are connected to each other. So let's go ahead to the second terminal and type in admin.peers here as well. There you go. Shows you a value here as well. All right, so that's good. You have a connect blockchain network, but how do we know for sure that this blockchain is up and running? So let's put it to test, shall we? Let's update something in node 1 and see if that change is propagated through the blockchain network to node 2. So let's go back to node 1 and type in miner.start, open and close parenthesis, and hit enter. So this is going to take quite some time. So meanwhile, what have we done so far? We have two terminal windows open, one running get console for node 1 and the second running get console for node 2. Node 1 saves its local copy of the blockchain in the BLK chain 1 folder. Node 2 saves its local copy of the blockchain in the BLK chain 2 folder. Also in the previous step, you connected the two nodes using admin.addpeers. Thus, if the new blocks are mined and added in node 1, this new block should propagate over the blockchain network and the local blockchain copy of node 2 should update automatically. So let's just wait until some mining occurs on the node 1. So as you can see, there are this symbol of this hammer, which means mined potential blocks. So you can see as the blocks are mined in node 1, there are some changes happening in the node 2 as well. So to check how many blocks have been mined at node 1 at any point, run the following in the get console. Eth dot block number and hence it should show you 3 blocks have been mined. So you'll notice that the block height in node 1 is 3. So let's go ahead and try the same in node 2. So you can see the block height or the block numbers match. So this verifies that the blocks that were mined in node 1 were propagated over the blockchain to node 2. To kick it up a notch, you can verify the data in the actual blocks on node 1 and node 2 by using this command eth dot get block, say the second block, and we'll do the same here as well. Eth dot get block of the second block. Now as you can see, both node 1 and node 2 have the exact same information. So you have now a fully functional and connected multi-node private Ethereum network. Happy coding, guys. Bye bye.